For quiz 6 for Math 112, we're told we have this function. It's a transformation of the cosine function that passes through these points. Okay, so maybe that'll help to graph things a little bit. So let's see, I have 0, -3. So 1, 2, 3. Going through this point right here, and then going through pi, -3. So maybe that's pi over 2, and this is pi out here. And it tells me that these are minimums, consecutive minimums at that, and it has a maximum value of 5. 1, 2, 3, 4, 5. So if the minimums are at 0 and pi, the maximum would have to be at pi over 2, halfway in between those two. So really the graph that I'm talking about is one that looks something like this. Okay, and what I'm trying to figure out are a lot of things. First off, what's the amplitude? One way you could figure out the amplitude is it is always going to be, well, it's the distance from the midline to the top. And you're like, right, but I haven't figured out the midline yet. Okay, well, without the midline, you can figure it out by figuring it's the half the distance from the top to the bottom. So it is y max minus y min. That gives me the distance from the top to the bottom. I want half the distance, I'll divide it by 2. So the maximum value appears to be 5. The minimum value is -3. And so 5 minus -3 is 8. And divide that by 2, you get 4, which is the amplitude here. For the midline is kind of the average height. Well, if it goes from -3, well, okay, there's a few ways you can do it. Maybe the easiest way would probably be it's always the average of the maximum value and the minimum value. So I'm going to take those two things, add them together, and divide by 2. I'm going to get 5 plus -3 divided by 2. And that's 2 divided by 2, aka 1. And you can talk yourself into that in the picture. Sure, that looks like that could be about the middle of this graph here. And then the distance from here up here, yep, that's 4. Distance from here down here, that's 4 also. Okay, cool. Things seem to be working out. Period is how long it takes to recycle. This thing completes an entire cycle in a length pi. So the period is just equal to pi. I don't know. Distance between consecutive minimums would be one way you could justify that. Now it says, assuming that the phase shift is pi over 2, determine the equation of the function. In other words, find a, b, c, and d in this expression here. Okay, well, the absolute value of a is equal to the amplitude. And I figured out up here that the amplitude is equal to 4. So I know that the absolute value of a is equal to 4. Right, so what is a? Well, I guess it could be +4 or -4. But this is kind of worded confusingly. But it tells me the phase shift. It says the phase shift is pi over 2. So here's pi over 2 right here. It's saying this is the starting spot. So this is the starting spot. My graph continues and it goes like this. If this is the starting spot for a cosine graph, the orientation is normal. It starts at the top like it's supposed to. So what that tells me is that a is +4, and maybe I'll say because orientation is normal with this phase shift. And you can see that up here. If this is the starting spot, the orientation is normal. B, okay, B is, I can find based on the period, 2 pi divided by b is always equal to the period. And the period I figured out above was pi. So I got 2 pi over b equals pi. So 2 pi is equal to b times pi. And therefore 2 is what b is equal to if you divide both sides by b, or by pi, sorry. It's kind of running together, so maybe I'll move over here somewhere. What about C? Well, C is the phase. C can be found based on the phase shift. So it's stated that the phase shift is pi over 2. So I get that pi over 2 is equal to -c over b. The phase shift is always equal to -c over b. But b I figured out was 2. So I got pi over, that's not pi. Pi over 2 equals -c divided by the 2 that I figured out b was equal to. So you probably just stare at this and figure out that c equals -pi. In order to make this the same as this, I got to get rid of the negative, so negative, and then change the c into a pi. Either that or solve for it algebraically. One way or another, you get that c is equal to -pi. I've already figured out that b is equal to 2 and that a is equal to 4. So all that remains is to figure out d, and d is kind of an easy one. D is just the midline. So d equals the midline, which I figured out above is 1. So there's A, B, C, and D. And then for part E down here, you're asked to kind of do this again. Determine the equation of the function, so come up with this thing. But now the phase shift is 0. So now instead of this being my starting spot, this is my starting spot. And that's fine. You can start at the bottom with the cosine graph. You just have to recognize that your orientation is switched. So what that tells you is that A no longer equals 4. A now equals negative 4. That's to change orientation. That's what this negative right here is doing. And then I want negative 4 times the cosine of b is still the same because the period is the same. So 2x plus c. C is still the same. No, it's not. C is not the same. The phase shift is now 0. So I get 0 equals negative c over b. So that tells me that c is equal to 0. So I could put a plus 0 here if I felt like it. Don't need that. Plus d, the midline, that is the same, plus 1. So I'll say that, or negative 4 cosine of 2x plus 1. Okay, moving on down here, fill out the chart. So to fill out the chart, it kind of helps to know what cosecant, secant, tangent, and cotangent look like. So I think the easiest way to come up with those is to sketch a graph of the sine curve. So something like this. Here's 2 pi. Here's pi. Here's 0. And this thing continues in both directions. And from this, I can come up with the graph of cosecant. If this is y equals sine of x. Cosecant of x is the reciprocal of this. So I'm going to have a vertical asymptote anywhere this has a height of 0. Because 1 divided by 0 is undefined. So I'm going to have this vertical asymptote here, and another one here, and here, and so on. And to fill in the rest of the values, the graph is going to end up looking like this. Where that comes from is when the height of the green graph gets smaller and smaller, closer and closer to 0, 1 divided by a really small number turns into a really large number. So you get this kind of shape right here. So for I guess this graph is y equals cosecant of x, and let's see if we can answer some questions about it. Has a vertical asymptote at x equals 0? Yep, sure does. Has x-intercepts? No, this thing in red never crossed my x-axis. Has a period of 2 pi? Yep, sure does. This thing will repeat when I get 2 pi. When I draw the next one, it'll look like this. Passes through the point 0, 1? No, it doesn't pass through 0 anything because it's got a vertical asymptote at 0. So that would be an n right there. I can do something similar to come up with the graph of secant, except now I'm going to start with the cosine. So this is y equals cosine of x, and that's 0. This is pi, and this is 2 pi. And I won't bother drawing all the details of secant. I'll just note that I'll have asymptotes anywhere the height of the cosine graph is 0. So I'll get my asymptotes there. My graph will look like this. And that should be enough for me to fill out, to answer all the questions. So let's see, has a vertical asymptote at x equals 0? No, it doesn't look like it. So I'll put a no here. Has x-intercepts? No, the red never crosses the x-axis. Has a period of 2 pi? Yeah, sure does. It repeats when I get over to here. Passes through 0, 1. I think this will. Right, here is 0, 1 right there. I know that's 0, 1 because the height of cosine when my x value is 0, when my input is 0, is 1. And 1 divided by 1 is just 1. We get a y there. All right, tangent. Yeah, I guess I'll do this on a separate axis. Tangent is sine over cosine. So the sine graph looks like this. This is y equals sine of x. And the cosine graph looks like this. And this is y equals cosine of x. And so what I want to draw is something that is the height of green divided by the height of blue. Well, I'm going to have a vertical asymptote anywhere the height of blue is 0. Maybe I should have labeled some points here. This is 0, this is pi, and this is 2 pi. So let's see, I want the height of green divided by the height of blue. Well, 0 divided by 1 is just 0, so I'll get a graph like this. And then my denominator is getting bigger as my numerator is getting, my numerator is getting bigger as my denominator is getting smaller, which means this thing is going up like this. It'll turn out it has that same behavior over on this side. End up with a graph that looks roughly like this. This is y equals tangent of x. And I can answer all the questions. First off, does it have a vertical asymptote at x equals 0? Nope. First vertical asymptote happens at pi over 2. First positive, I guess. So that's an n. Does it have x-intercepts? Sure does. Looks like it crosses the x-axis a bunch of times. So I'll put a y here. Has a period of 2 pi. No, it actually has a period of 1 pi. This thing repeats every 1 pi, as you can see from the picture. So this would be an n. And passes through 0, 1. See, what's the height? No, it passes through 0, 0. So it can't pass through 0, 1. So that would be an n right there. Last one. Maybe I can do it in another color. Sure. This is going to make this really messy, but I'm going to do it anyways. Now let's do y equals cotangent of x. For cotangent of x, it's the same idea, except now it's cosine over sine instead of sine over cosine. So since it's cosine over sine, I'm going to have a vertical asymptote anywhere the height of sine is 0. Anywhere my red graph has a height of 0, I'm going to get a vertical asymptote. So my graph is going to look like, or so my asymptotes will be here, and there. And then I can kind of do the same analysis I did with the red graph. At this point right here, the cosine height is 0. 0 divided by 1 is 0, so it'll go through that point, and similarly it will go through that point. And over here, between my asymptote and this 0, both the blue and green graph have positive values. And a positive divided by a positive is a positive, so the black graph should have a positive height here. It's going to end up looking something like this. Ugh, that's pretty ugly. Let me try that again. Sure, good enough. I think that'll be enough for us to answer all of these questions. First off, note that it does have a vertical asymptote at 0. So I'm going to go ahead and put a y right here. Does it have x-intercepts? Sure, there's one. There's another one. Yes. Does it have a period of 2 pi? No, the period of cotangent is the same as the period of tangent. You can see this thing repeats every 1 pi. So I'll put an n there. Does it go through the point 0, 1? No, it can't, because there's a vertical asymptote at x equals 0. So it couldn't possibly go through that point. I'll put an n there. I've now filled out my chart completely. So I guess I've answered this question. Maybe I'm even going to say pictures are optional, so that when people turn in the quiz, they don't all ask me, oh, I didn't know we had to do this. You don't. This is just me drawing this to justify these answers to try to help you out. All right, that ends this quiz.